My dear students, welcome to my video class. Today I am going to discuss Bayes train theory. It's a very important topic. This theory explains the stability of cycloalkanes. Theory explains stability of cycloalkanes. Okay. Let us discuss the details of the theory in this session. Why Bayes introduced an equation to calculate angle of cycloalkanes. He introduced an equation to calculate angle of the cycloalkanes. The angle is equal to interior angle is equal to 180 minus 360 by n degree, where n is equal to number of sides. For this one, n is equal to 3 side. For this one, n is equal to 4 side. For this one, n is equal to 5 sides. For this one, n is equal to 6 sides. For this one, n is equal to 7 sides. 1, 2, 3, 4, 5, 6, 7 sides. Now let us calculate the angle of each one. For cyclopropane, okay. For cyclopropane, 180 minus 360 divided by 3, that is 180 minus 120, that is 60. For this one, 180 minus 360 divided by 4, that is 180 minus 90, that is 90. For this one, 180 minus 360 divided by 5, 180 minus 360 divided by 5 is equal to 1.5 degree. Okay, that is 180 minus this is 108 degree. Okay. For this one, for this one, 180 minus 360 divided by 6 is equal to angle is 120 degree. For this one, 7 ring, 180 minus 360 divided by 7 is equal to 128.6 degree. These are the angles. Okay. Now, what are the postulates of Bayes theory? You remember this how he calculated the angle. The first postulates of Bayes theory. Postulates of Bayes theory. Okay. He calculated the angle using that equation. From that, he calculated the postulates also. He first postulates cycloalkane cycloalkanes are planar. That is, this is planar triangle. This is square planar. This is pentagon. Hexagon, etc., etc. He said that cycloalkanes are planar. Second, ideal bond angle. Ideal angle is 109 degree 5 minutes. That is the third postulate. Ideal angle of cycloalkane is 109 degree 5 minutes. Third, in cycloalkane, actual angle is deviated from ideal angle 109 degree 5 minutes. 109 degree 5 minutes. That is, in cycloalkane, actual angle is deviated from ideal angle. Next, fourth is, this deviation is called the deviation is called angle strain. The deviation is called angle strain. Fifth postulate, I am discussing all the postulates. The fifth postulate is, more the deviation from ideal angle, less the stability. Okay, these are the postulates of Bayes' theory. Cycloalkanes are planar. Bayer considered that cycloalkanes are planar molecules. They are planar molecule. According to him, every cycloalkanes are nothing but planar molecules. Okay, he believed like that. Second, he postulated that ideal angle of a cycloalkane is 109 degree 5 minutes. Ideal angle is 109 degree 5 minutes. But every cycloalkane has a deviation from this angle, ideal angle. And that deviation is called angle strain. What is angle strain? Angle strain is the deviation of cycloalkane from its ideal angle 109 degree 5 minutes. More the deviation, less the stable. Now, he prepared a chart of stability and deviation. Let us see the chart. Compound, I just draw that. Angle, their actual angle, ideal angle, we know that ideal angle. Now, deviation, remark. Okay, let us see the chart in detail. Okay, first let us take this cycloalkane, cyclopropane. Its angle is 60 degree, 109 degree 5 minutes. Deviation is 109 degree 5 minutes. 109 degree 5 minutes minus 60. What is the deviation? the deviation is 49 degree 5 minutes. This is the first deviation. Okay. Now second is cyclobutane 90 degree. This is the ideal angle. The deviation is 19 degree 5 minutes. 90 degree, the difference 109 degree 5 minutes, the difference. Now next is cyclopentane 120 degree 109 degree 5 minutes. The deviation, I am sorry, here I am really sorry, the angle is 108. The angle is 108. I think in the previous video I have done some error. If any error, please correct it. 108 degree. This is 109 degree. Therefore, the deviation is 1 degree 5 minutes. 1 degree 5 minutes. Okay, 1 degree 5 minutes. Now cyclohexane 120 degree 109 degree 5 minutes. The angle is minus 10 degree 5 minutes. Minus 10, because this is larger. Now next is the angle is 128 degree 5 minutes, 6 minutes. I'm really sorry, 5 minutes, 5 or 6, something like 6. This is 109 degree 5 minutes. The difference is 19 degree 1 minutes. Therefore, here the maximum deviation less stable. Here the minimum deviation more stable. Therefore, according to Bayes' theory, the most stable cycloalkane is cyclopentane. According to Bayes' theory, the most stable cycloalkane is nothing but cyclopentane. Okay. The stability order is, this is the number 1 stability, this is the number 2 stability, this is number 3 stability, this is number 4 stability, this is 5th stability. Therefore, the stability order is, this is least stable, then this one, then 7-membered ring, then 6-membered ring, then 5-membered ring. That is the stability order, my dear students. According to Bayes' theory, 5-membered is more stable than 6-membered. Underline the word. According to Bayes' theory, 5-membered ring is more stable than 6-membered. According to Bayes' theory, 5-member is more stable than 6-member, but actual stability 6-member is more stable than 5-member. That we will discuss in later. Now, this Bayes' theory has been supported by heat of neutralization of cycloalkanes. Heat of neutralization of cycloalkane, that or delta H0 combustion. Okay, if a cycloalkane is less stable less stable, its delta H0 compression value will be higher, that will be higher, because it has higher potential energy. Because less stable means more energy, less stable means more energy. Therefore, when it compresses, this excess energy will be released. Therefore, heat of compression will be higher. If it is less stable means it will have higher potential energy. Students, listen me. If it is less stable, it will have higher potential energy. This higher potential energy will be released as heat of compression when it reacts with the oxygen or when it is burnt. Therefore, less stable, more heat of compression. Now, let us check heat of compression of different heat of compression of CH2 per CH2 group of cycloalkane. Heat of compression of per CH2 group of cycloalkane. That is cyclohexane, then cyclopentane, cyclobutane, then cyclopropane. The value is 166.6 kilojoule per mole. This is 164 kilojoule per mole. This is 158.7 kilojoule per mole. This is 157.4 kilojoule per mole. Here a little discrepancy. I said to you, cyclopropane is most stable according to base theory, but actual sense, we now believe that, we now proved that cyclohexane is more stable than cyclohexane. This is only most stable according to base theory. Remember that point. This is only more stable according to base theory. But anyway, base theory says that cyclopropane is least stable. That is already proved in base theory. That is supported by heat of compression also. According to heat of compression, it has the highest value. That is, it proves that in terms of heat of compression, in the view of heat of compression, cyclopropane is least stable. According to base theory also, cyclopropane is least stable. Therefore, base theory is partially correct. It was the first theory in the 18th century. Alfred Baer was awarded for the Nobel Prize in this discovery. It was a benchmark theory because it was done in 18th century. Okay. Anyway, now we have more sophisticated theories and more advanced theory, but it is still valid. This is all about the cyclohexane and cycloalkane and their stability. Now I am going to discuss limitations of base theory. It has some limitation. First limitations. First, it consider cycloalkynes are planar. It is not true. Only propane is planar. Rest are non-planar. That's the first problem. Second, I said to you, cyclohexane is more stable But in theory, in this theory, cyclopentane is more stable. Cyclopentane is more stable. This is the problem. Second problem. Third, it consider only angle strain. It do not consider torsional strain and steric strain. Therefore, you may ask me why Bayer failed in the case of cyclohexane and cycloalkane. The reason is that Bayer only considered angle strain, but the stability of cycloalkanes not only depends upon angle strain but also depends upon torsional and steric strain. Therefore, when you consider these three strains together, cyclohexane is more stable. Okay, that is discussed in another theory, that is not scope of our syllabus. Anyway, thank you for watching. If you have any doubts, let us discuss in future. Thank you.